Good day everyone. I'm Nandini. Now I'm going to talk about a multi-terminal HVDC system. First, let's see what is meant by an HVDC system. An HVDC system is nothing but an electric power transmission system which uses a high voltage direct current to transmit the electric power between the sending end to the receiving end. Normally, an HVDC system is used to transmit power between longer distances since we require a rectifier and the inverter unit at the sending end and the receiving end, which becomes expensive for shorter distances. Generally, it can be installed for a distance of 500 km or more. HVDC system has an advantage that it can interconnect the system operating at different frequencies. HVDC system requires a less number of conductors and insulators when compared to AC transmission system, thereby reducing the overall loss of the system. An HVDC system also have a lesser amount of corona loss, conductor loss and skin effect when compared to that of an AC transmission system. This is the general layout of an HVDC system. As we know, in generating station, the power is generated in the form of an AC. The AC power generated is given to the step-up transformer. The high voltage AC is given to the rectifier which converts AC to DC and transmits it with the help of a DC transmission line. At the receiving end, the inverter converts the DC back into AC and it is given to a step-down transformer. From there, the voltage can be fed to the utility terminals. It is the basic principle of operation of an HVDC system. These are the major types of an HVDC system: back-to-back system, two-terminal system, and a multi-terminal system, which is further subdivided into series and parallel system. Back-to-back HVDC system. Here, both the rectifier and the inverter are placed within the same station and are connected back to back with each other. Here, there is no need for the DC transmission line since they are placed within the same station. It is used to connect to a network or a grid operating at different frequencies. Two-terminal HVDC system. Here we can have two different stations, the rectifier station and the inverter station. These two stations are connected with the help of a DC transmission line. This also called as a point-to-point transmission system since there is no intermediate tappings. It is used to transmit the electric power from one point to another which are very far from each other. It is the normal type of HVDC system that are being used. Now let's see about a multi-terminal HVDC system. It is just an extension of a two-terminal HVDC system. Here we can have any number of rectifiers and inverters which can be connected with each other, which means that multiple converters can be placed here. As we said, we can have any number of rectifiers and inverters connected with each other. The balance principle is that the total amount of current supplied by the rectifier should be equal to the total amount of current drawn by the inverter. The power demand of the inverter can be met by increasing the value of voltage or current. So here we need to monitor and control the value of voltage and current. Here we cannot use an AC circuit breaker on AC side because it will de-energize the whole DC network instead of isolating the specific line having fault. Therefore, here we have a multiple DC circuit breakers placed at the place where we require to isolate the circuit having a fault. So it results in the perfect isolation. An advantage of an empty DC system is that if one of the generating station fails, the supply to the inverter is retained with the help of another station. For example, if this station fails, still the supply is retained with the help of this supply. Therefore, it is an advantage over the other systems. It is of two types, series and parallel. In series MTDC system, we have multiple inverters and rectifiers connected in series with each other. As we know, in a series circuit, the current remains the same and the voltage will get varied. Here, it operates in the same way. The current through the circuit remains the same and the voltage at each place will vary. Therefore, the power demand is met by changing the value of voltage. This change in value of voltage makes it difficult to control the circuit and also it is difficult to meet the insulation requirement of the circuit. This system uses a monopolar DC link where the line is grounded at one point. However, a ground capacitor can be used to protect the circuit against the transients. It has a disadvantage that if any one of the line fails, it results in the blackout of the entire circuit. For example, here if the line fails, the circuit will get open and the entire system will have a blackout. It is a disadvantage of this system when compared to the parallel system. Parallel MTDC system. In parallel MTDC system, we have multiple inverters which are fed from a single rectifier. As shown, we have a single rectifier which supplies a multiple inverters connected with each other. Just like in a parallel circuit, the voltage across the circuit will remain the same and the current through the circuit will vary. Therefore, here the power demand is met by changing the value of the current. When more power is required, then more current is injected into that circuit. Here it is an advantage that if any one of the line fails, it will just result in the isolation of that circuit alone. Here if it fails, then it will isolate this circuit alone and the current through the other circuit is retained. The, cur- the power reversal can be done with either current reversal or voltage reversal. Here we are using a voltage source converter so that the voltage will remain the same and the current can be varied to meet the power demand. Whereas if we use the current source converter, the current will remain the same and the voltage is varied. When the voltage is varied, it will result in the collapse of the entire system. So, the voltage source converters are used for the parallel MTDC system rather than the current source converters. It is of two types, which is the radial main system and the ring main system. A radial MTDC system. Here, the single rectifier supplies the several inverter station. Here we have a several DC circuit breakers placed at the end of the lines. Here, the isolation of one circuit will result in the isolation of at least one or more inverter station. For example, if the isolation is here, if a fault occurs and this circuit is isolated, then these three will be isolated from this main circuit. And a fault occurs here, only this will be isolated. So it will result in isolation of one or more circuit. It is overcome with the help of a mesh or ring type MTDC. Here we have the single rectifier which supplies the multiple inverters. Here this is connected in such a way that if this line fails, then the supply to the station is just retained by this line. So here the isolation, here the blackout is never a cause of failure in this circuit. Advantages of an MTDC system. It is economical. Since the HVDC requires a lesser number of conductors and the losses are less, it is economical when compared to a AC system. Environmental. The construction of HVDC requires a low right of way when compared to the construction of HVAC. So it is environmentally friendly. Since the losses are very less in HVDC, its efficiency is good. There is no need for the reactive power compensation. Here, as we know, the power reversal is achieved with the help of a current reversal, not by the voltage reversal. Applications of MTDC. It connects multiple DC renewable energy farms to multiple power grids. Here, we can have a several generating stations connected to the several receiving stations. The multiple offshore film farms, which can be of any distance from each other, is connected to the power grid. It allows the connection of two systems operating at different frequencies. It can offer a power to the several inverter stations with the help of a single rectifier station. So, these are the overview of an MTDC system. Thank you.